So diving right into chapter 11's material. So let's see here. Might help if I'm on the pencil. Okay, chapter 11. Our first lesson corresponds to these things called radical expressions. Now you might be like, okay, Austin, Mr. A, what the heck? We already did radical functions. Why are we doing this again? We already tested over it. We're done. Well, we did radical functions. Okay, we learned how to graph radical functions. But now what we're going to do is we're going to kind of take a step back. And we're going to look at expressions involving radicals instead of functions involving radicals. In some senses, they're a little easier to deal with. But in other senses, this is probably one of the harder chapters later on in the chapter for students to really grasp the material on. So I'll try to make it as easy as possible, and I'll give like really good examples for you to go through the assignments and stuff like that. So first things first, what is a radical expression? We were introduced to a radical function. I think we covered the square root of x and the cube root of x and the graphs of those, what those looked like. We saw that the square root of x graph kind of looked something like this, and we saw that the cube root of x graph looked something like this, the sideways s and the sideways parabola, but just half of it. We saw that those were functions that we were able to graph. Well, we're not going to be graphing radical expressions. Instead, what we can do is we can learn how to simplify things like, well, we already know how to do this one. Root 64 we already know is just 8, but let's say we get something like the square root of 91. Or let's say we get the fourth root of 108. Simple things like that, we don't know how to really break this down because we don't know what the fourth root of 108 or the square root of 91 is to give an exact answer. By the end of this chapter, we'll be able to break both these numbers inside down enough to where we can get a solid answer, and we'll be able to work with it. So, as a little aside, let's get rid of those. What I'm going to focus on is the different parts of a radical expression. So let me formally define what a radical expression is. So a radical expression, in fact, that's fine, I'll keep it red. A radical expression is an expression of the form. So I'm going to use a little notation here. It's nothing too crazy, but bear with me. I'll explain what each part is. It looks something like this. Okay? Where this check mark corresponds to the radical part of radical expressions. This little n here corresponds to the index. Okay, we'll get more into what that means and how we can use that later. And the little expression inside the radical corresponds to the radicand. Okay, so I do ask on one of the problems for you to identify the radicand and the index of given radical expressions. Very, very simple to do so long as you follow this format. The little number that corresponds right here is the index. What's inside of the radical is called the radicand. Okay? I'll give you a minute to sort of soak that in. There is one other little aspect that I want to dive into before I get into more complicated radical expressions and how we're going to use them. I'm going to erase all of this. So the next little thing I want to get into is these things called rational power expressions. Okay, rational power is the key here. So I'm going to change back to black so that way we can get it distinguished. So a rational power expression is basically just that. It's an expression, I'm just going to have it as A, that has a power that is a ratio. I'm going to write it as P over Q. Okay? P and Q are numbers. Specifically, they're natural numbers, but just for the sake of argument, they're just numbers. Basically, what this says is we're taking something like a, whatever that may be. It may be x, it may be a number, it's something. And we're raising it to a fractional power. Okay? So some examples of rational power expressions could be something like x to the 1/3. That's an example of a rational power expression. We could also have something like 3x squared to the 3/2. That is also a rational power expression. You can kind of get the hint here, but here's a couple more. I could do something like x to the 3/5 raised to the 2nd. Okay, that's an example of a rational power expression. Basically, you're looking for something that is inside something that is being exponentiated. Okay, 2 is technically a rational number. We'll learn later on that you could take this 2 and simplify it a little more, but that's for next lesson. So basically, you're looking for something that is raised to a power that looks like a fraction. That is an example of a rational power expression. So I ask you to identify or to translate between a radical expression and a rational power expression. This is what I mean, and I'll get to in a little bit. This is the form that you use for a rational power expression. Okay. So in the next video, I am going to actually get into translating between the two different types of expressions.